Alright, just did half that video and realized I didn't hit record, so we'll try this again. This is 3.5, slopes of lines. The objective is to find the slope of a line, use slopes to identify parallel and perpendicular lines. There's your wonderful vocabulary. First word is slope. This is not a buzzword. Not a buzzword. The slope of a line in a coordinate plane is a number that describes the steepness of the line. Any 2 points on a line can be used to determine the slope. Basically, what you need to know is slope represents the steepness. So this line has a slope. This line has a different slope. This line has a slope, 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 slope. All those lines have slopes. All right, this should be a fairly easy review for us from Algebra 1. If a slope exists, there is a rise and a run. Rise is the difference of y values. Run, which is your first buzzword, is the difference of x values. Slope is, we use m for slope, is rise over run. This should be, again, fairly familiar for us. We've got from this point to this point, we rise +6 and we run +4. So our slope is 6 over 4, which reduces to 3 over 2. This is the equation for a slope, which we should be familiar with. If not, you do need to have this. If you are familiar, you still need to have this written down. If not, make sure you remember this equation. It's y2 minus y1 equals x2 minus x1. Notice again how we did our distance formula and our midpoint formula. This x1, y1 is going to pair up in 1 point. x2, y2 is going to pair up in 1 point. Your y's are going to be on top. Your x's are going to be on bottom. Your 2 values will be paired up, and your 1 values will be paired up. So you should always kind of have a double type of check to make sure you're doing it right. The y's on top, x's on bottom, 2's in a row, y's in a row, or 1's in a row. All right, use the slope formula to determine the slope of each line. So for AC, first we have to find the point A. It is at -2, 7, and point C is at 4, 2. All right, midpoint formula, or slope formula, sorry, tells me to do y2 minus y1 over x2 minus x1. I am going to go ahead and pick 4, 2 to be my 2 points because C is written second. AC, I'm going to pick this to be point 1. This is going to be point 2. Formula reads as 2 minus 7 over 4 minus -2. This is my y2 value. This is my y1 value, x2, x1. 2 minus 7 is -5. 4 minus -2 is +2, so we have 6. The slope is -5 over 6. Okay, remember a fraction with 0 in the denominator cannot happen. If you put it in your calculator, 3 divided by 0, you get error or undefined or syntax error. That is because you can't divide by 0. So when that happens, you will have an undefined. These are the 4 types of slopes. You're going to have a positive slope going from left to right, it's going up. Left to right, you're going down. Left to right, it's 0. And this is vertical up and down. So positive, negative, 0, undefined. So what we're going to do is think of a little skier. He's going to be a Star Wars skier. He's skiing up the slope. He's putting positive effort into this. He's working out a lot, so he's positive energy. Over here, he's falling down the ski. He's doing the, slalom or something. He's going down. He's not putting any effort into this. He's just kind of skiing down the slope. Here, he's just standing here. He's not going anywhere. 0. He doesn't go up or down. By the time he gets to here, we're going to call this the undefined. Because if he's skiing along and a cliff comes and he falls, he dies. So when it is a vertical slope up and down, it has to be straight up and down. It is called undefined. Our interpretive slope is a rate of change. If y represents miles traveled, okay, that's for the next example. And x represents time in hours, the slope gives us the rate of change in miles per hour. So like I just said, this one is going to do a story problem based on the distance. So let's read it. Justin is driving from home to his college dormitory. At 4 p.m., he is 260 miles from his house. At 7 p.m., he is 455 miles from home. Graph the line that represents Justin's distance from home at a given time. Find and interpret the slope of the line. That wonderful graph has already been done for us. Now we need to interpret the graph. Again, like that last slide said, The slope is the rate of change. So you're simply just putting this point and this point into the slope equation. So I'm going to pick this to be 0.1 and this to be 0.2. Undefined is your second buzzword. Undefined is your second buzzword. So for example 2, I'm going to continue. I'm going to do 455 minus 4 or minus 260. This is y2 minus y1. Now I'm going to put that over 7 minus 4, x2 minus x1. I get 195 over 3, which reduces to 65 over 1. So in terms of this story problem, find and interpret the slope of the line. He is driving 65 miles per hour. All right, these are the theorems you need to know for the slope of a parallel line. Slope of parallel and perpendicular line. Parallel lines mean two non-vertical lines are parallel if and only if they have the same slope. So basically what you need to know here is parallel lines are two lines that have the same slope. Perpendicular lines have opposite reciprocal. They're called opposite reciprocal. In a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slope is -1. Vertical and horizontal lines are always perpendicular. All right, so if a line has a slope of a over b, and then the slope of the perpendicular line has to be -b over a, this is called opposite reciprocals. That is your third buzzword, is opposite reciprocals. So two lines that are perpendicular have opposite reciprocals. So if one line is 5 over 2, its perpendicular line is going to be opposite is negative, the reciprocal would be 2 over 5. These two slopes are perpendicular to each other. 4 given points do not always determine two lines. Graph the lines to make sure the points are not collinear. Side note there for you. All right, example 3, we just got 3A, I guess. 3 last equations, or 3 last examples real quick. Graph each pair of lines, use slopes to determine whether the lines are parallel, perpendicular, or neither. All right, so again, I've already got the graph on here. You need to graph these lines based on the points. Graph 3, 1, and 3, -2. Because WX is 0.31 and 0.3, -2, that's where you draw your line. At -2, 3, and 4, 3. Plot these points, YZ, draw the line. All right, you need to find the slope. The slope of YZ is 0. It's the flat line. The slope of the red is a vertical line. Our skier just fell off the cliff, so he died, so he's undefined. If two slopes are 0 and undefined, they are in fact perpendicular. So we are going to say WX is perpendicular to YZ. All right, same thing. Graph, slope, determine what they are. So I'm going to do KL first. So I've got, I'll do L as my 0.2. -3 minus 4 over -2 minus -4. And I get -3 minus 4 is -7. -2 minus -4, so I'm adding 4, is going to be +2. Slope of the red line is -7 over 2. Now, if the blue line is 2/7, then they're perpendicular. It has to be 2/7 because it would be the opposite reciprocal of this. So let's see. Again, you're gonna say, well, they look perpendicular, so I'm going to say they're perpendicular, but you have to show that they are. So let's do MN. N is going to be 0.2, so -1 minus 1. Or not -1. Yes, -1 minus 1. And then -5 minus 3. All right, -1 minus 1 gives us -2. -5 minus 3 gives us -8. This reduces to 1 over 4. 1 over 4 is not the opposite reciprocal to -7 over 2. So line KL and MN are not parallel. Let's say KL and MN. Not parallel or perpendicular. So they're neither. All right, last one. BC and DE. BC, 1, 1, and 3, 5. So again, we should be getting pretty quick at this. Slope of BC is 5 minus 1 over 3 minus 1. Y2 minus Y1 over X2 minus X1. This is going to give us 5 minus 1 is 4, 3 minus 1 is 2. This is a slope of 2. Okay, so the slope of the red line is 2. Slope of the blue line, again, you're going to say it looks parallel, but what happens if maybe in this part of the diagram they do look parallel, but maybe way up here somewhere they do actually cross. So we have to see whether they do or not. DE is -2, -6, and 3, 4. So 4 minus -6 over 3 minus -2. Okay, 4 plus 6 is 10. 3 plus 2 is 5. This reduces to 2. Since they are both 2, we can say that they are parallel. So 2 is parallel to, or BC is parallel to DE because their slopes are both 2. And that's it.